So today we will try to finish this chapter. This chapter is again very important for your GPAT, Niper and other exams. So if you have analyzed the previous year's papers, अगर आपने previous year के papers देखे होंगे तो उसमें काफी questions आ जाते हैं आपके sterilization chapter में से. So what is basically sterilization? Sterilization means removal of any viable form of organism. Removal or killing of all viable form of microorganism. That is viable मतलब any viable मतलब सभी forms, ठीक है. It may be either vegetative or spores. So removal of all kind of forms of microorganism. Pyrogens also. Pyrogen, vegetative forms, spore forms, etc. etc. So the process of removal of all kind of organism from your preparation, that is a sterilization. So this term you might have encountered in the various subject like pharmaceutics also during the parental products, during the preparation of that microbial media growth medium, during the preparation of growth medium. So you have to sterilize that growth medium so that there is no another contamination in the growth medium. So what is meant by aseptic technique? It is again a technique, it is a process, it is a tool to make all the possible contamination of microorganism right from the beginning. So what is aseptic technique? To prevent the all kind of contamination. पहले से ही आप इतना केयर करो कि उसमें कुछ कंटेमिनेशन आए नहीं. So उसको बोलेंगे aseptic technique. So aseptic technique is nothing but the technique or process or tool in which all possible contamination of microorganism that can be prevented to getting enter into your product being processed. That is aseptic condition by using different kind of air technique. For example, HEPA filters, then laminar air flows, then UV chambers. So you have to overcome all kind of probable contamination. So you are preventing all kind of probable contamination so that final product will be sterile. So that is aseptic condition. So basically these large volume parentals and your injections and parental preparation, they are processed by aseptic technique. Now there are two terms, disinfection or disinfectant and antiseptics. So what is meant by disinfection? Destruction or removal of all pathogenic microorganisms capable for giving rise to infection. Okay, so all kind of chemical agent which can destruct or kill the pathogenic organism which are responsible for the infection. So that is known as a disinfection. The process is known as a disinfection and the agent is known as a disinfectant. Now mostly these disinfectant, these are the chemicals applied on the non-living objects like your glass slides or your any utensils or your floor. Okay, so disinfectant. Now there is another term known as a antiseptic. Now antiseptic is again a chemical agent that is applied on the skin or mucous membrane to prevent the infection or to kill the microorganism. Then methods of sterilization. Again you have to remember the classification of method. Sometimes they can ask question on this classification. So first is the physical method. In that you use sunlight, drying sunlight or normal day sunlight for drying. So you might have seen घरामध्ये बघा आपल्या काही वाळायला घालतात. काही गोष्टी जसे जर तुमच्या म्हणजे कुठलंही पीक असेल तुमच्याकडे तर ते पीक आपण काय करतो सनलाइट मध्ये पूर्ण वाळवतो सो दॅट इट कॅन बी विल लास्ट लॉंग. ठीक आहे. जर शेंगदाण्याचं पीक असेल तुम्ही शेंगदाणे वाळवून ठेवता ते बऱ्याच दिवस टिकावं म्हणून. सो दॅट इज अ सिम्पल. दॅट इज ऑल्सो वन ऑफ द स्टरलायझेशन टेक्निक. In physical only you have dry heat. In the physical itself you have dry heat. In this case flaming, incineration and hot air. So flaming you use for sterilization of your inoculating loop. So microbiology में अगर अपने inoculation loop जो है उसको एक flame से पास करते हो to inoculate the before inoculating the microorganism or culture. So you have to make that loop sterile. So how can you make sterile? By passing through a flame of your burner. Then incineration means to burn it totally. Then hot air. So hot air is the basis for your hot air one or dry heat sterilization. Again in the physical you have moist heat. So pasteurization, then boiling, steam under normal pressure, steam under pressure. So this steam under pressure is the basis for autoclaving, sterilization by autoclave, steam under pressure. Again mechanical method of sterilization or physical method of sterilization is nothing but the filtration. So you are using here bacteria proof filters. So filter candle, asbestos pad or filters, then membrane filters. So particularly these membrane filters are very important. Their pore size and that is important. We'll see it in the upcoming lectures. So membrane filters are, remember, bacteria-proof filters, filter candle, asbestos pad filters, etc. So using this, bacteria will be entrapped into the filtering medium. Only sterile liquid will be available in the filtrate. So filtration. So remember, dry heat moisture filtration is also a mechanical method or physical method of sterilization. Now chemical method, okay, radiation is also one of the physical method. In the radiation, you have two kind of radiation. So non-ionizing radiation and ionizing radiation. So UV comes under non-ionizing radiation. Then gamma rays, okay, then X rays that comes under the ionizing radiation. The ultrasonic and sonic vibrations also. Remember, dry heat, moist heat, filtration, and radiation sterilization. All these are this comes under the physical method of sterilization. Chemical method of sterilization. So using different kind of chemicals. That might be either liquid, that might be either gas, or that might be either chemical. Okay. So first is a okay, first alcohol. So in this alcohol you have ethyl alcohol, isopropyl alcohol, trichlorobutanol. Particularly, this isopropyl alcohol is used for sanitization purpose. So sanitize करने के लिए इसको use करते हैं isopropyl alcohol. Then aldehydes like formaldehyde and glutaraldehyde. Then certain gases are also there. So certain surface active agent like cetrimide, phenols, dyes and all. Okay, surface active agent. Then gases like ethylene oxide, formaldehyde, then beta propanolactone. These are the gases. So remember, under physical method, dry, moist, filtration and radiation. Under chemical methods, you are different like alcohol, aldehyde, then then okay, then quaternary ammonium compound like your cetrimide and all that. Surface active agents, gases, gases में आता है आपका ethylene oxide, formaldehyde, beta propanolactone. Now, what is meant by sterility? Sterility means total absence of your any form of microorganism. So, okay, so total absence of any form of microorganism. That is nothing but the sterility. So it is very important to maintain a sterility in case of your parenteral products, okay, or those products which are introduced into body directly. Sterility is nothing but the total absence of all forms of microorganism. Okay, sterility. Then antiseptic is nothing but the chemical agent capable or able to kill the microorganism when applied it on the body, applied it on the skin or mucous membrane. Then disinfectant is nothing but the chemical agent that can kill all kind of organism, and it is normally applied it on the inanimate object like floor, tables, utensils in the context of your chemical method of sterilization. जो केमिकल मेथड जो है स्टरलाइजेशन की, जैसे अल्कोहल यूज करते हो, एल्डिहाइड यूज करते हो, फिनॉल यूज करते हो, ठीक है, जो केमिकल मेथड है उसमें आपका देयर आर टू टर्म्स related to chemical method for sterilization. First one is known as the decimal reduction time. It is known as a D value, decimal reduction time or D value. So what is it? It is nothing but the time of disinfectant required to reduce the 90% of total population. मान लीजिए कि वहाँ पे कुछ 100 कॉलोनीज है बैक्टीरिया की, तो कितने टाइम में एक एक आपका डिसइंफेक्टर वो 100 कॉलोनीज को 90% कम करता है. सो टाइम ऑफ डिसइंफेक्टेंट रिक्वायर्ड टू रिड्यूस द पॉपुलेशन ऑफ माइक्रोऑर्गेनिज्म by 90% or by 1 decimal of 90% is 1 log of 90%. Then there is another term known as the thermal destruction time. It is known as the Z value. Don't worry, these terms are going to come in again. So Z value or thermal destruction time, it is a degree of temperature required to reduce the 1 log of D value. That means to produce a 10-fold change in the D value. जो थर्मल रिडक्शन टाइम है आपका, उसमें अगर 10-fold चेंज करना है तो उसके लिए कितना टेम्परेचर लगेगा? सो दैट इज नथिंग बट थर्मल डिस्ट्रक्शन टाइम. सो थर्मल डिस्ट्रक्शन टाइम इज द Z value and decimal reduction time is nothing but the D value. So you have to remember, don't get confused in these two terms: thermal reduction time, then the decimal reduction time and thermal destruction time. Decimal reduction time क्या है? Time of disinfectant required to reduce the 90% of total population of bacteria. Now thermal destruction time और Z value क्या है? The degree of temperature required to reduce the or to produce the 10-fold change in the D value. तो एज इट इज इसके ऊपर क्वेश्चन आ चुका है. सो जेड वैल्यू इज नथिंग बट द टेम्परेचर रिक्वायर्ड टू. ओके, और जेड वैल्यू इज नथिंग बट द, और नीचे ऑप्शन में था टू रिड्यूस द जेड वैल्यू, टू मेक द 10 फोल्ड चेंजेस इन द डी वैल्यू. ऐसा दो चार ऑप्शन थे. सो रिमेंबर जेड वैल्यू इज नथिंग बट द thermal destruction time, that is the temperature required to reduce the 1 log of d value, or in the other sense you can say to make the 10 fold changes in the d value. तो 10 गुना चेंज करना है डी वैल्यू में, उसके लिए कितना टेम्परेचर लगेगा, उसको बोलते हैं जेड वैल्यू. डी वैल्यू किसको बोलते हैं, कितना टाइम लगता है कोई डिसइंफेक्टेंट को, जो ओरिजिनल पॉपुलेशन है बैक्टीरिया का, उसको 90% कम करने के लिए, जैसे 1 लॉगरिथमिक. सो दैट इज अ थर्मल डिस्ट्रक्शन टाइम. तो यहाँ पे आप ऐसा भी याद रख सकते हो, थर्मल डिस्ट्रक्शन टाइम और डी वैल्यू. तो यहाँ पे टाइम आता है, उसमें टाइम टर्म आता है. डेसिमल रिडक्शन टाइम मींस द टाइम ऑफ डिसइंफेक्टेंट रिक्वायर्ड टू रिड्यूस द 90% ऑफ बैक्टीरिया. ओके, थर्मल डिस्ट्रक्शन टाइम मींस द टेम्परेचर रिक्वायर्ड to change 10 to make a change for to make a 10 fold change in the d value. Okay, क्वेश्चन इसके ऊपर आ चुका है. Then different method of sterilization, as I have seen, we have seen already yesterday, but still for recording purpose I have to take it once again. So different methods for sterilization. So each and every single method has a different mechanism, different advantages, different disadvantages. Okay, I'm not going in the detail of advantages and disadvantages because that is not important for UGPAT. So what is important for UGPAT? The method of sterilization, the holding temperature is very important. Then the mechanism of sterilization in that method, that is very important. So we will see one by one. Method, holding temperature or mechanism, holding temperature and mechanism, and then application in a very short. So first one is known as a dry heat sterilization. So for dry heat sterilization you are using hot air oven. So what is the holding temperature? 180 degrees Celsius for 2 hours or 260 degrees Celsius for 45 minutes. If anything, particularly the glasswares, the media, etc., etc. So you have to subject it for a hot air oven at a 180 degrees Celsius for 2 hours or 260 degrees Celsius for 45 minutes. Then only all kind of organisms will be killed. It will become sterile. Okay. So what is the mechanism how this dry heat kills the bacteria? What is the mechanism behind the killing? Okay. So this is the mechanism behind the killing. That is oxidative damage. Oxidative damage किसको? Oxidative damage to the bacterial enzymes. Oxidative damage to the bacterial enzyme responsible for the its metabolism. So obviously enzyme को ही डैमेज हो जाएगा, मर जाएगी, एंजाइम ही डिस्टर्ब हो जाएगी, तो मेटाबॉलिज्म नहीं होगा. अगर मेटाबॉलिज्म नहीं होगा तो वो जिंदा कैसे रहेगा? सो ऑक्सीडेटिव डैमेज एंड डीनेचुरेशन ऑफ बैक्टीरियल प्रोटीन. बैक्टीरियल सेल की जितने अंदर प्रोटीन है उसका डीनेचुरेशन भी करेगा. So oxidative damage and denaturation of bacterial protein. Remember mechanism as it is आ चुका है. What is the mechanism behind dry heat? What is the mechanism behind moist heat? या फिर आपको different मेथड देंगे, एक कॉलम में, दूसरे कॉलम में देंगे मैकेनिज्म, बोलेंगे फाइंड द करेक्ट मैच और मैच द फॉलोइंग टाइप ऑफ मेथड ऑफ स्टरलाइजेशन विद द रिस्पेक्टिव मैकेनिज्म इन ऑल. ठीक है, एक कॉलम में देंगे आपको मेथड्स, दूसरे कॉलम में देंगे टेम्परेचर, ये मैकेनिज्म. रिमेंबर इन केस ऑफ ड्राई हीट स्टरलाइजेशन, oxidative damage and denaturation of bacterial protein. Okay. Now dry heat sterilization is used for the glassware, sterilization of glassware and other metal instruments. So जितने भी glassware होते metal instrument जो होते powders होते या फिर oily injections. So glasswares and other metal instruments, powders and oily injections, they are sterilized by dry heat sterilization. एक बार फिर से रिपीट करता हूँ आपके लिए. So what is dry heat sterilization? So by using only heat, dry heat, so you have to sterilize the utensil, glasswares, powders, instruments, okay, metal instruments, then oily injections by using only dry heat, as that in a hot air oven. Okay, what is the holding temperature? So you can subject that material or utensil for 180 degrees Celsius for 2 hours or 260 degrees Celsius for 45 minutes. Now what is the mechanism? Oxidative damage and denaturation of protein. Remember the applications we have seen, glassware and other metal instruments, powder and oily injection. Now second one is a moist heat sterilization. Moist मतलब क्या? इसमें आपका steam आएगा. So moist मतलब steam आएगा. Moist heat sterilization. So what is the holding temperature and mechanism? Holding temperature is nothing but the 115 to 117 degrees Celsius for 30 minutes. So there are different holding temperature under the autoclave depending upon the application. इसका application क्या क्या है 121 डिग्री सेल्सियस for 20 मिनट 121 डिग्री सेल्सियस for 15 मिनट ऐसा बहुत सारे होल्डिंग टेम्परेचर देखिए. So moist sterilization में याद रखो 150 1150 to 117 डिग्री सेल्सियस for 30 minutes. Now what is the mechanism? Here again denaturation of protein and most important mechanism, that is nothing but the coagulation of protein. Coagulation of protein. Coagulation of protein. तो आप याद रखो कि आप जब अंडा उबालते हो, सो अंडा ले लिया आपने, मुर्गी का अंडा उबाला उसको. अंडा अंडा में क्या होता है कि सिर्फ प्रोटीन ही होता है. सो अंडा में फ्लूइड प्रोटीन होता है, लिक्विड प्रोटीन होता है, और जब आप उसको उबालते हो तो वो सॉलिड बन जाता है. So that is a perfect example of your coagulation of protein. प्रोटीन का कोएगुलेशन का एग्जांपल है कि आप जो अंडा उबालते हो, उकड़लेले अंडे खातात ना, तो उकडणं म्हणजे काय, तर बिकॉज ऑफ दैट स्टीम देयर इज अ कोएगुलेशन ऑफ प्रोटीन इनसाइड द एग. जो एग के अंदर लिक्विड प्रोटीन है उसका कोएगुलेशन होता है एंड वो क्या बनता है, सॉलिड बनता है. डिस्ट्रक्शन और डीनेचुरेशन ऑफ प्रोटीन इज डिफरेंट टर्म. सो डीनेचुरेशन ऑफ प्रोटीन मीन्स व्हाट? सो ए लॉस ऑफ नेटिव स्ट्रक्चर ऑफ प्रोटीन. प्रोटीन का स्ट्रक्चर कैसा है, उसका लॉस हो गया अगर ड्यू टू हीट, ओके, दैट इज नोन एज द डीनेचुरेशन ऑफ प्रोटीन. कोएगुलेशन ऑफ प्रोटीन मींस, सो कोएगुलेशन will also will also will also make a changes in the structure, but there will be precipitation of protein or there will be solidification of protein. Okay, so remember, in case of dry heat, oxidative damage and denaturation of protein is the mechanism. In case of moist heat, there is a denaturation as well as coagulation of bacterial protein. But in case of moist heat, mostly bacteria die because of the coagulation of bacterial protein. And in case of dry heat, bacteria dies because of the oxidative damage to the enzyme and denaturation of protein. The enzyme भी क्या होते हैं? They are also a protein in nature. Then remember, this moist heat is used for the sterilization of heavy fluids, rubbers, and plastic containers. Now next method is a tyndallization. Tyndallization is nothing but also known as a fractional sterilization. Tyndallization is also known as a fractional sterilization. In this method, heating the medium at 80 degrees Celsius for 1 hour. Heating of medium 80 degrees Celsius for 1 hour. That is a holding temperature in the tyndallization. 100 degrees Celsius for 20 minutes. Okay, for successive 3 days. तो हर दिन में क्या करना है आपको, एक तो 80 डिग्री सेल्सियस पे 80 डिग्री सेल्सियस पे उसको 1 आवर हीट करना है और जो बाकी रख देना है. फिर से दूसरे दिन वही प्रोसेस करना है, फिर से तीसरे दिन वही प्रोसेस करना है. दैट इज नोन एज अ फ्रैक्शनल स्टरलाइजेशन. फ्रैक्शनल स्टरलाइजेशन, heating of medium or anything that is to be sterilized for at 80 degrees Celsius for 1 hour for successive 3 days. Or another method is that heating of medium at 100 degrees Celsius for 20 minutes for successive 3 days. This method is used for the sterilization of surgical dressing and culture media. Next we see what is pasteurization. Pasteurization is the term that is after the Louis Pasteur. It is a pasteurization term after the Louis Pasteur. He developed the method pasteurization of milk. So milk जो आपका जो heat करते हो, that is done by sterilization of milk is done by pasteurization. Okay. So there are 3 methods. So first holding temperature is nothing but 62.8 degrees Celsius for 30 minutes. It is known as a Holder's method. Okay. So heating of medium or milk at a 62.8 degrees Celsius, that means 63 degrees Celsius for 30 minutes. आधे घंटे के लिए हीट करना है आपको 62.8 डिग्री सेल्सियस. That is known as a Holder's method. Another holding temperature is there, that is heating of milk or medium at a 71 to 72 degrees Celsius for 15 seconds. And it is known as a flash method. Third method is heating of that medium or milk at a 140 degrees Celsius for less than for more than 1 second. For more than 1 second, एक सेकंड में उसको हीट करना है 140 डिग्री. सो रिमेंबर दिस मेथड्स. इसके ऊपर नाम याद रखो, ये नाम के ऊपर क्वेश्चन आता है. व्हाट इज द होल्डिंग टेम्परेचर इन द होल्डर मेथड, व्हाट इज द होल्डिंग टेम्परेचर इन द फ्लैश मेथड. ओके, ऐसा क्वेश्चन आता है. इन द पास्चराइजेशन यू हैव 3 डिफरेंट होल्डिंग टेम्परेचर. फर्स्ट इज द 62.8, that is for 30 minutes, known as a holder method. 71 to 72 71-72 degrees Celsius for 15 minutes or 15 seconds. That is known as a flash method, and third method is nothing but the 140 degrees Celsius for less than 1 second तो होता नहीं लेकिन 1 second ही तो more than 1 second. These are the three holding temperature in the pasteurization. This method is used for the sterilization of milk, popularly known as the pasteurization of milk. Pasteurization of milk, popularly known as the pasteurization of milk. Now next one is a radiation sterilization method. So the इलेक्ट्रोमैग्नेटिक रेज जो होता है यूवी रेडिएशन जैसे आपका gamma radiation, okay, so those also they are also used a tool for sterilization. So first is nothing but the in that UV, okay, first one is ultraviolet rays, okay? So for production of this UV or for emission of this UV rays, so mercury vapor lamp is used. So mercury vapor lamp is used to produce the UV rays that will emit the UV rays at a 253 nanometer UV, okay. Now what is the mechanism of UV rays? It will damage to the nucleoprotein of the microorganism. तो आपको डीएनए के डैम जो माइक्रोबियल का डीएनए है उसको डैमेज करता है कौन? यूवी. दैट इज द मैकेनिज्म. सो व्हाट इज द मैकेनिज्म? इट विल डैमेज द न्यूक्लिक एसिड. Now ionizing radiation. So UV comes under non-ionizing radiation. UV comes under non-ionizing radiation. Now ionizing radiation. So what is the mechanism? Denaturation and damage to the DNA and enzymes. So denaturation, damage to the DNA of bacteria, damage to the enzymes of bacteria, and other components of microbial. So formation of free radicals that occurs in the gamma rays. Okay, gamma rays and beta rays, they damage the bacteria by forming a free radical which will react with the DNA and enzymes, and that will render bacteria inactive. It will kill the bacteria. So remember UV में क्या होता है? It will damage to the DNA और nucleoprotein. Ionizing radiation भी DNA को damage करता है, enzymes को damage करता है, and other component of bacterial cell. So जो ionizing radiation है particularly they form a free radical, and that free radical reacts with the different component of bacteria. Okay, particularly DNA, RNA, and enzymes. Okay, so gamma rays and beta rays they are mostly used. So now this irradiation sterilization, okay, radiation method for sterilization is also known, okay, is also known as a cold sterilization. Is also known as a cold sterilization. Remember, it is known as a cold sterilization. Radiation sterilization is also known as a cold sterilization. That is used for the thermolabile substances. Okay, to maintain aseptic technique also used in the hospital. UV chambers are available. Okay, you might have seen UV chambers. So again, thermolabile substances like plastic, syringes, catheters, needles, surgical dressing, and blades. So for thermolabile substances, if you want to sterilize the thermolabile substances, thermolabile मतलब क्या है? Those substances or those utensils which are heat sensitive. तो अगर आप रबर को स्टरलाइज करने जाओगे ड्राई हीट में तो रबर क्या होगा? पिघलेगा और खराब हो जाएगा. अगर रबर को आप ऑटोक्लेव में स्टरलाइज करने जाओगे तो वहां पे वो पिघलेगा, ठीक है. बट रबर में कुछ एडिटिव्स वगैरह करके जरा हार्ड रबर है तो नहीं पिघलेगा. And that's why most of the rubber products or plastic products like syringes, catheters, needles, surgical dressings, okay, they are sterilized by this radiation sterilization method, because radiation sterilization does not involve the heat. इसमें कोई heat नहीं होता, ठीक है. That's why it is known as a cold sterilization. So radiation sterilization is also known as a cold sterilization method, याद रखो, and it is used for sterilization of thermolabile substances. Now next method is a gaseous sterilization. In that, as the name indicates, यहाँ पे क्या है gases, तो इसमें क्या यूज करना है? gases. उसे गैस यूज करेंगे इथिलीन ऑक्साइड, फॉर्माल्डेहाइड, बीटा प्रोपेनोलैक्टोन. ठीक, थोडंसं लवकर येत चला प्रियंका मगरे, थोडंसं लवकर येत चला. ओके, थोडंसं नाही म्हणजे प्रॉपर टाइमलाच येत जा. gaseous sterilization. So gaseous sterilization means you are using different kind of gases which will damage the bacteria. So particularly ethylene oxide is the gas, then formaldehyde and beta propiolactone, beta propiolactone, ethylene oxide and formaldehyde. Okay. Now what is the mechanism involved in the killing of bacteria? कैसे मारेंगे ये बैक्टीरिया? So this is the mechanism. Okay. So they are all these gases are nothing but the alkylating agent. They will cause alkalization of, okay. They will cause alkalization of hydroxyl group, carboxyl group, and sulfhydryl groups of bacterial protein. So what they do, they causes alkalization. यहाँ पे मिथाइल रेडिकल को ऐड करेंगे, जो भी हाइड्रोक्सिल ग्रुप जहाँ पे होगा वहाँ पे मिथाइल रेडिकल ऐड करेंगे. उसके बाद में carboxyl group, sulfhydryl group जो है. So you have seen in the protein में have hydroxyl group, sulfhydryl groups, PO2 sulfur containing amino acids, particularly cysteine. जो cysteine होता है उसमें sulfhydryl group होता है, ओके. जो cysteine होता है उसमें थायोईथर ग्रुप होता है, और जो मिथियोनिन होता है उसमें डाइसल्फाइड, ओके. याद रखो उसको, इसमें किसका बॉन्ड होता है वो भी इंपॉर्टेंट है. Okay. So gaseous relation में आपका ethylene oxide, formaldehyde and beta propane lactone, and all they cause alkalization of different groups of bacterial protein like hydroxyl group, carboxyl group, sulfhydryl groups. Okay. Now they are again used for the thermolabile substances. जो temperature temperature, okay, those substances which are not tolerate, which cannot tolerate the temperature. So these are nothing but thermolabile. So again, this gaseous sterilization is for thermolabile substances, plastic material, rubbers, fumigation, then fumigation of operation room, sterilization and fumigation for aseptic room also. Fumigation for operation room. तो हर एक ऑपरेशन के पहले क्या करते हैं कि उसको ऑपरेशन थिएटर को स्टरलाइज करते हैं, बेड वगैरह सब कुछ रहता है वहाँ पे, ऑपरेशन टेबल वगैरह. सो दे हैव टू sterilize the operation theater before every single surgery, okay. So for that they used to do one thing. So there is one container, in that container they used to they used to pour the formalin solution or formaldehyde solution and formalin solution properly. Formalin solution उसमें pour करते हैं और उसमें बाद में KMnO4, that is known as पोटेशियम परमैंगनेट, वो डाल देते हैं. पोटेशियम परमैंगनेट उसका ऑक्सीडेशन करता है और फॉर्मेलिन का फॉर्माल्डेहाइड बन जाता है. तो फॉर्माल्डेहाइड फ्यूम पूरे रूम में फैल जाता है और दैट इज नथिंग बट इट विल डिसइंफेक्ट ईच एंड एवरी कॉर्नर, ईच एंड एवरीथिंग. एयर को भी डिसइंफेक्ट करता है. फॉर्मालिन एंड formalin solution and potassium permanganate, it is used for the fumigation of operation theatre. So thermolabile substances they are sterilized by gaseous and radiation sterilization. Then operation of fumigation of operation room, sterilization of aseptic rooms. So remember this method. So out of that, this radiation sterilization is known as a cold sterilization. जो पाश्चराइजेशन है, हॉट एयर ओवन है या फिर ड्राई हीट स्टरलाइजेशन है आपका मॉइस्टिटी, उसमें तो हीट आता है. रेडिएशन स्टरलाइजेशन में हीट नहीं आता, तो इसलिए क्या बोलते हैं उसको कोल्ड स्टरलाइजेशन और कोल्ड मेथड ऑफ स्टरलाइजेशन. नाउ अनदर मेथड इज देयर स्टरलाइजेशन बाय फिल्ट्रेशन, तो इसको भी कोल्ड स्टरलाइजेशन बोलते हैं. स्टरलाइजेशन बाय फिल्ट्रेशन, स्टरलाइजेशन बाय फिल्ट्रेशन. देयर आर सम बैक्टीरिया प्रूफ फिल्टर्स. Filter, first one is a filter, candle filters. So in that you use unglazed ceramic filters or diatomaceous earth filters. तो ये उसके टाइप्स हैं. Then asbestos filters. So they are also carcinogenic in their nature. जो asbestos filter होते हैं वो क्या है, carcinogenic nature होते हैं. Then sintered glass filters, prepared by fusing the finely divided glass particle. Prepared by fusing the finely divided glass particle. Sintered glass filters, they are prepared. They are made by making the powder of glass, okay, and then fusing that powder, okay. Membrane filters, they are made up of a cellulose or उसके polymers. So membrane filters. Then radiation sterilization में क्या है आपका non ionizing low energy radiation कौन सा है, UV and IR. So they will damage the DNA of your bacteria. Then ionizing radiation which will have high energy, okay, they will have high energy. जो रेडिएशन स्टरलाइजेशन को मैंने कोल्ड मेथड बोला था, एक्चुअली वो रॉन्ग है. सो दैट रेडिएशन स्टरलाइजेशन इज नॉट अ कोल्ड स्टरलाइजेशन. दिस फिल्ट्रेशन स्टरलाइजेशन इज नोन एज अ कोल्ड स्टरलाइजेशन. फिल्ट्रेशन स्टरलाइजेशन इज नॉट अ कोल्ड स्टरलाइजेशन. क्योंकि रेडिएशन में क्या होता है कि अगर आयोनाइजिंग रेडिएशन यूज किए तो उसमें हीट जनरेट हो सकता है. सो आयोनाइजिंग रेडिएशन दे कैन इंक्रीज द हीट, ओके. सो रिमेंबर कोल्ड स्टरलाइजेशन इज नथिंग बट द स्टरलाइजेशन बाय फिल्ट्रेशन. Ionizing radiation like X-ray, gamma rays and cosmic rays, they have very little effect on the genetic material and other vital constituent of microbes. देन केमिकल स्टरलाइजेशन, केमिकल में डिफरेंट केमिकल यूज करते हैं. सो फर्स्ट वन इज अल्कोहल्स. First one is the alcohols. So ethanol, isopropyl alcohol, okay, trichloroethanol, most frequently used. They act by denaturation of bacterial protein, but they will not kill the bacterial spore. Alcohol होता है, they will destruct the bacteria, vegetative form of bacteria, by denaturation of bacterial protein, but they will not affect the bacterial spore. Next one is the aldehydes. aldehydes का mechanism देखो, उसमें maximum formaldehyde use करते हैं. Formaldehyde that interact with the amino acid of the protein of microorganism and mostly used as a preserve. It is mostly used to preserve the anatomical specimens. तो anatomy lab में देखा होगा आपने, किसी का लीवर पड़ा है, उसके उसमें एक solution रहता है. So formalin और formaldehyde. So formalin, okay, formaldehyde gas is widely used for disinfection of your operation theaters. Formaldehyde gas की वजह से fumigation करते हैं. Next one is the phenol. So phenol, lethal effect or sidal effect of this phenol is because of their capacity to combine with the cell membrane and damage the cell, resulting into releasing the cell content into, जैसे बैक्टीरिया है उसका सेल मेम्ब्रेन को डैमेज करता है फिनॉल. डैमेज होने के कारण क्या होता है कि अंदर का जो भी कंटेंट है उसका वो बाहर आ जाता है, मर जाएगा वो. ओके, सो फिनॉल्स दे डैमेजेस द cell wall of your bacteria, cell membrane of bacteria, and they will cause leaking of content inside the cell. Okay, that's why bacteria will die. That is the mechanism of phenol. Phenol कैसे act होता है ये भी आता है. Now next one is ethylene oxide. It's a gas, ethylene oxide. So it causes alkalization of different groups like carboxyl, hydroxyl, then sulfide groups of different proteins and enzymes. Halogens like chlorine and all that. So particularly chlorine is used for the disinfection of water. Chlorine किसके लिए यूज करते हैं? Disinfection of water. In case of halogens, iodine is a strong oxidizing agent. Chlorine is also oxidizing agent. So it causes oxidation of important bacterial components. So क्लोरीन जो है it is used for the disinfection of water. तो आप अगर म्युनिसिपल कॉर्पोरेशन का पानी पीते हो उसमें क्या होता है? क्लोरीन होता है, क्लोरीन ऐड करते हैं. तो iodine is also oxidizing agent. And heavy metals. So heavy metals they cause denaturation of enzymes which are very important or essential for the proteins and other. Okay, so these halogens or heavy metals, okay, heavy metals cause denaturation of enzymes and other essential proteins of bacteria, and this will bacteria die. In surface active agents, so there are different surface active agents like anions, cationic, anionic. Okay, so anionic is one of the sodium lauryl sulfate. Okay, so it is also used as a disinfectant. So होता है ना, कोरोना में बोला था आपको हैंड सैनिटाइजर, हैंड सैनिटाइज करने के लिए आप क्या करो, अगर नहीं कोई सैनिटाइजर मिलता तो सोप से भी कर सकते, उससे थोड़ी बैक्टीरिया मरता है because that your soap or shampoo that has a surface active agent that is known as sodium lauryl sulfate. So because of that there is a, okay, so this surface active agent, they might be either cationic, anionic. Cationic like example benzalkonium chloride. Then again cetrimide is a cationic surfactant. It causes disruption of enzyme and denaturation or protein denaturation. They cause disruption of the bacterial enzyme and also causes the protein denaturation. Surface active agents. Methods of sterilization and their validation तो स्टरलाइज हुआ है या नहीं हुआ है. ठीक है, आपने क्या किया कि ऑटोक्लेव में डाला है कुछ स्टरलाइज करने के. सो इफ यू यूज मीडिया एंड इफ यू स्टरलाइज दैट मीडिया बाय यूजिंग ऑटोक्लेव, बट हाउ कुड यू नो whether that media has been totally sterilized or not. क्या आपने स्टरलाइज तो किया लेकिन आपको कहाँ दिख रहा है कि उसमें बैक्टीरिया दिख रहे क्या है आपका आंखों से? नहीं. whether it is being completely sterilized or not, how you can know? So there are certain methods validation of this particular sterilization process. तो क्वेश्चन इसके ऊपर डोंट गो इन द डिटेल कि मेथड का पूरा कैसा होता है क्या होता है. सो व्हाट दे यूज्ड टू आस्क एजेंट, फिजिकल मेथड, chemical method and biological method used for the validation of your sterilization method. Physical, chemical, biological indicators होते हैं उसके लिए. So what are the different physical, chemical and biological indicators for validation of your method of sterilization? So first one is nothing but the dry heat sterilization. So dry heat sterilization के लिए validation कैसे करेंगे? Recording of temperature by physical means. recording of temperature by physical means that is mean by that is nothing but the thermometer जो होते हैं बड़े बड़े उसमें टेम्परेचर मेजर कर सकते हो। वो आपको मालूम होता है कि बैक्टीरिया ये जो बैक्टीरिया इस टाइप की बैक्टीरिया जो है एक 40 एक 60-70 डिग्री के आगे नहीं जिंदा रहेगी। यू कैन set the 100 degrees Celsius temperature for regular time. So recording of temperature by physical means, then this Brownian's tube is Brownian's tube इसके ऊपर क्वेश्चन आ चुका है। Brownian's tube is the physical indicator for evaluation of dry for evaluation of dry sterilization. Brownian's tube इसके ऊपर क्वेश्चन आ चुका है। Brownian's tube is nothing but the is a physical indicator validate the dry sterilization. Brownian's tube एक ट्यूब होता है उसका मैकेनिज्म क्या है वो that is not important. So it will give you in the color. Okay, that is a green spot. Green spot means the material is been totally sterilized, absence of any. Then उसमें दूसरा भी आता है Bravi Dick heat sensitive tape. Bravi Dick heat sensitive tape वो भी आता है. That is for though these two used for the chemical validation. Okay? Physical validation में ये आता है. Okay? Then chemical validation में क्या आता है? Chemical indicators में आता है आपका Brownian's tube and Bravi Dick heat sensitive tapes. याद रखो इसमें physical indicator, chemical indicator and biological indicators होते हैं. तो first आता है आपका physical indicator. Physical indicator means recording of temperature by different thermometers. Okay. Now second one is a chemical indicator. What is chemical indicator? In that you have two different. First one is nothing but Brownian's tube. This was a physical. Now this is a chemical indicator. Brownian's tube and Bravi Dick heat sensitive tapes. Bravi Dick heat sensitive tapes. These are known as a chemical indicator. Okay? क्योंकि ये बिफोर स्टरलाइजेशन उनका कलर अलग रहेगा। जैसे इंडिकेटर होता है आपका, जैसे आपका एसिड बेस स्टार्टेशन में एक इंडिकेटर होता है तो उसका नॉर्मली कलर आप जैसे phenolphthalein, so it's a colorless, but when the pH it will be neutral it will get colorized, so like that. So Brownian's tube and Bravi's Dick heat sensitive tape, these are the chemical indicator for dried sterilization. Chemical indicator used for the validation of dried sterilization. Again biological indicators इसके ऊपर भी क्वेश्चन आ चुका है. What are the biological, which of the following bacterial spore is used for the biological indicator, used as a biological indicator for validating the right sterilization? So remember question आ चुका है. Spores of bacteria Bacillus subtilis. Spores of bacteria known as Bacillus subtilis. ये Bacillus subtilis के spores use करते हैं for the dry sterilization validation. So spores of Bacillus subtilis were निगा Clostridium tetani spore उसके भी यूज करते हैं. They are used as a biological indicator. ठीक है, ये इसके ऊपर मैं और एक बार बोलता हूँ आपको क्योंकि ये इंपॉर्टेंट है. ड्राइड स्टरलाइजेशन मेथड का वैलिडेशन कैसे करेंगे? बाय फिजिकल, केमिकल एंड बायोलॉजिकल इंडिकेटर. बाय फिजिकली, so you can check the temperature by means of thermometer. Chemically you can validate the dried sterilization by using these two. First one is Brownian's tube and this Bravi Dick heat sensitive tapes. So chemical validation. Biologically you can validate dried sterilization by using spores of this Bacillus subtilis niger. Okay, Bacillus subtilis याद रखो. Then Clostridium tetani. These two are used as a spores of these two are used as a biological indicator for dried sterilization. Then next one is a moist heat sterilization. So the biological indicator for moist heat sterilization. Again spores of Bacillus stereothermophilus. Question इसके ऊपर भी आ चुका है. So biological indicator are used in the validation of moist heat sterilization. That is nothing but the spores of Bacillus thermophilus. Then again this Clostridium sporogens is also used. So biological indicator में आता है इसका spores of Bacillus thermophilus and Clostridium sporogens. Okay, and then autoclave tapes, thermocouples, they comes under the physical indicator. Okay, autoclave tapes and thermocouples they comes under the physical indicator. Biological में आता है Bacillus thermophilus, Clostridium sporogens, spores of Bacillus thermophilus and क्लोस्ट्रिडियम स्पोरोजेंस, ये बायोलॉजिकल इंडिकेटर होगा। थर्मोकपल्स क्या होगा, फिजिकल इंडिकेटर होगा। ये ऑटोक्लेव टिप्स क्या होंगे, केमिकल इंडिकेटर है। ये ऑटोक्लेव टिप्स दैट इज केमिकल इंडिकेटर एंड थर्मोकपल जो है दैट इज अ फिजिकल इंडिकेटर। Now third, sterilization by radiation. So chemical validation of sterilization by radiation. So chemical dosing metals, they are used for validating the radiation sterilization by chemically. Validation of radiation sterilization by biological indicator. So bacillus humilus and surface crust, these are the used as a biological indicator. Spores of bacillus humilus, cephrecus, okay, and cephrecus, bacillus humilus and bacillus cephrecus, they are used as a biological indicator. क्वेश्चन इसके ही ऊपर आता है कौन सा इंडिकेटर। देन फोर्थ मेथड इज गैसियस स्टरलाइजेशन। सो इसमें इसके ऊपर क्वेश्चन आया था रोशी सैचेट chemical validation. Then spores of Bacillus subtilis, they are also used as a biological indicator. Roshi sachet जो that is used for chemical validation of gaseous sterilization, and Bacillus subtilis spores, they are used for the biological indicator. Now fifth method is the sterilization by filtration. तो sterilization by filtration के लिए कौन से indicators होते हैं? So Pseudomonas diminuta, okay, Pseudomonas diminuta and Serratina mersens, they are used as a biological indicator. थोड़ा सा नाम मुझे भी लेने में दिक्कत होता है। Pseudomonas diminuta and Serratia mersens, so they are used as a biological indicator for validating the sterilization by filtration. Okay, so physical method इसमें आता है bubble point test and forward flow test, that is used to check the integrity of membrane filters. Physical method, membrane filters by physical method कौन से आता है, bubble point test and forward flow test. Again you can revise it, different method of sterilization and validation, different method of sterilization and indicators. Okay, so for moist sterilization, bacillus yeah, for moist sterilization, biological indicators are used as spores of Bacillus thermophilus and Clostridium perfringens. Then chemical indicators, autoclave tips are used and strip papers are used. For dry heat, you use spores of Bacillus subtilis as a biological indicator, and for this chemical indicator, you use brownish tube and brevidic heat sensitive tips. For gaseous sterilization or ethylene oxide sterilization, you use biological indicator as a spores of Bacillus humilus, and for chemical indicator, Roshi sachet. For radiation sterilization or by sterilization by filtration, ये दोनों sterilization के लिए biological indicator कौन है, देखो ये Pseudomonas diminuta, Serratia mercedes and Saccharomyces cerevisiae, ये फंगस होता है, Saccharomyces cerevisiae. And dosimeters, they are used for the chemical, they are used as chemical indicator for validation. Okay, now types of brownish tube के भी type होते हैं, जैसे brownish tube is used for the validation of dry heat sterilization by physical indicator, or sorry, chemical indicator for validation by dry heat sterilization. Brownish tube is used as a chemical indicator for validation of dry heat sterilization. उसके टाइप होते हैं टाइप 1, टाइप 2, टाइप 3, टाइप 4, टाइप 1, टाइप 2, टाइप 3, टाइप 1 brownish tube is, so it is used in the moist heat sterilization. वो temperature at a temperature 126 degrees Celsius, it will show black color spot, that means there is a complete sterilization. In the type 2 brownish tube, so it is used for high vacuum moist heat sterilization. So if temperature will go above 130 degrees Celsius, it will show yellow spot. यहाँ पर मैं एक क्वेश्चन भी आता है कौन सा टाइप ब्राउनिश ट्यूब और कौन सा कलर इंडिकेटर देगा। टाइप 3 में it is used for the dry heat, brownish tube type 3 dry heat. So it is when temperature will go 160 degrees Celsius, it will show green spot. ये देखा है आपने। Type 4, it is also used for dry heat. Okay, infrared conveyor oven, IR infrared की वजह से जो हीट पैदा होता है उसमें, so dry heat and infrared conveyor oven, when temperature will go 180 degrees Celsius, it will show blue spot. तो ये क्या याद रखो, ब्राउनिश ट्यूब के टाइप्स, ठीक है, और उसके कलर इंडिकेटर। ब्राउनिश ट्यूब टाइप फर्स्ट is used for the validation of moist heat. Okay, moist heat. So when temperature will go 126 will show black spot. Type 2 brownish tube, when temperature will go 130 plus and is used for the high vacuum moist heat, it will show yellow spot. Type 3, so is used for the only dry heat, when temperature will go 160 degrees Celsius, so it will show green spot. Type 4, it is used for the dry heat as well as infrared conveyor oven, so when temperature will go or exceed 180, it will show blue spot. आवाज आता है? Are you getting my voice clearly? It is very important that brownish tube and all chemical indicators, biological indicators, they are very used. Or terms used for the expression of resistance of bacteria for chemical disinfectant. कि यार बैक्टीरिया रेजिस्टेंस है या नहीं, उसके लिए कौन से terms used for the expression of resistance of bacteria for chemical disinfectants. D value we have already seen. It is nothing but the time in minute. Time in minute or time in minute at any temperature to destroy 90% of viable organism. That is a D value. What is D value? Decimal reduction time. A time in minutes at any temperature to destroy 90% of total population of viable organism. For example, it is denoted like this: D115 degrees Celsius, D121 degrees Celsius. मतलब decimal time at a 150 150 डिग्री मतलब 150 डिग्री सेल्सियस पे कितना टाइम लगता है बैक्टीरिया को 90% रिड्यूस करने के लिए. दैट इज ऐसे डिनोट करते हैं. जैसे आपने होल्डिंग टेम्परेचर रखा 121, सो व्हाट इज द थर्मल डेसिमल रिडक्शन टाइम? व्हाट इज द डेसिमल रिडक्शन टाइम at 121 degrees Celsius? Okay, so it may be either 10 20 minutes depending on the type of microorganism. Next one is the Z value. Z value means decimal reduction time. We have already Z value means this thermal destruction time. Thermal destruction time. Z value. So degree of temperature required to produce 10-fold change in the D value. So we have already seen this definition, but so Z value is the number of degree of temperature to reduce the or to produce the 10-fold change in the D value. That is a one logarithmic change. It is nothing but the heat resistance of microorganism to change to the change in temperature. Microorganism का resistance कितना है to the change in temperature? That is nothing but the Z value. ठीक है. Bacterial spore will have a Z value in range of 10 to 15 degrees Celsius. Bacterial spore जो होता है उसमें resistance 10 to 15 degrees Celsius तक resist करते हैं, उसके बाद में नहीं करते. So again, what is D value? Decimal reduction time. It is nothing but the time at any temperature to reduce or to destroy 90% of viable microorganism. Okay, Z value is nothing but the thermal destruction value. Okay, thermal destruction value or Z value. What is it? It is nothing but the number of degree of temperature required to produce the 10-fold change in the D value. Okay, as it is question दो बार आ चुके हैं इसके ऊपर. It is nothing but the heat resistance of microorganism to change in the temperature. बैक्टीरिया के स्पोर जो है will have a Z value in range of 10 to 15 degrees Celsius. Now another term is there known as the F value. What is the F value? So it is known as a unit of lethality. F value is known as a unit of lethality. Lethality. Okay. Lethal जो मतलब side lethal. So unit of lethality. It has been devised in the food industry called F value. मतलब ये food industry में यूज करती है. क्या? F value. अपने बाकी स्टरलाइजेशन में डी वैल्यू यूज करते हैं, जेड वैल्यू यूज करते हैं, लेकिन फूड इंडस्ट्री में ईएफ वैल्यू यूज करते हैं. यूनिट ऑफ लीथैलिटी. सो इट इज अ इक्विवेलेंट इन मिनट at 121 degrees Celsius for all. So capacity to destroy the spores as well as vegetative form of particular organism. So time in the minute required to destroy spores, all vegetative cells at a 121 degrees Celsius. That is the EF value or unit of lethality. Unit time unit. Now Q10 value. इसके ऊपर भी क्वेश्चन आ चुका है. Q10 value. इसके ऊपर आई थिंक लास्ट 2 साल में आया. Q10 value or temperature coefficient. So increase in the killing rate brought out by increasing the temperature by 10 degrees Celsius. 10 डिग्री सेल्सियस टेम्परेचर बढ़ाएंगे तो किलिंग रेट कितना बढ़ेगा? तो इंक्रीज इन द किलिंग रेट brought by increasing the temperature by 10 degrees Celsius. So Q for moist installation is about 14 and for dry installation is about 4 approximately. जैसे मान लीजिए कि 115 डिग्री सेल्सियस होल्डिंग टेम्परेचर है आपका एटोक्लेव का, उस टाइम पे डेथ रेट कितना है माइक्रो ऑर्गेनिज्म का, अगर आपने 115 की जगह 125 कर दिया तो 10 डिग्री सेल्सियस बढ़ा दिया, किलिंग रेट 14 टाइम से बढ़ जाएगा. जैसे ड्राई हीट में अगर मान लीजिए आपने 100 डिग्री सेल्सियस पे रखा है कुछ, तो उस टाइम पे जो किलिंग रेट है बैक्टीरिया का, अगर आपने 110 टेम्परेचर कर दिया तो वो 4 गुना बढ़ जाएगा. सो लाइक दैट. So Q10 value or temperature coefficient, that is the increase in the killing rate or increase in the destruction rate brought about by increasing the 10 degrees Celsius temperature. जैसे Q is nothing but the Q10 value. Q10 value for moist installation is around 14 and for dry heat for it is around 4 only. Now inactive factor, another term is there. Inactive factor. ये term सबको कोई नहीं, इसके ऊपर एक क्वेश्चन आता है. कौन सी भी क्लास में जाकर देखो. Inactive factor is nothing but the degree to which viable population of microorganism it is reduced by treatment. Inactivation factor क्या है? It is nothing but the degree to which viable population of microorganism is reduced. मतलब क्या? जो जिंदा जिंदा बैक्टीरिया है वो कितने मरे. Inactive factor is nothing but the degree to which viable population of microorganism is reduced by treatment applied. मतलब जो भी आप अगर आपने डिसइंफेक्टेंट यूज किया है या फिर टेम्परेचर यूज किया है, ड्राई हीट हो रही या फिर कोई गैसेस यूज किया है, उसके कारण सो डिग्री टू विच वायबल पॉपुलेशन ऑफ माइक्रो ऑर्गेनिज्म इज रिड्यूस्ड, कितना डिग्री कम हुआ है उसको बोलते हैं इनएक्टिवेशन फैक्टर. एंड ऑब्टेन बाय डिवाइडिंग द इनिशियल वैल्यू बाय फाइनल वायबल काउंट. इनिशियली वायबल काउंट करते हैं बैक्टीरिया, कितना बैक्टीरिया है उसमें, और उसके बाद में ट्रीटमेंट अप्लाई किया आपने, जैसे फिनॉल डाल दिया उसमें कुछ अमाउंट कॉन्सेंट्रेशन में, या फिर ड्राई हीट को सब्जेक्ट किया या फिर मॉइस्ट हीट को सब्जेक्ट किया, उसके बाद में फिर से चेक करना है वायबल काउंट. तो डिग्री टू विच वायबल पॉपुलेशन ऑफ माइक्रो ऑर्गेनिज्म इज रिड्यूस्ड बाय स्पेसिफिक ट्रीटमेंट, दैट इज इनएक्टिव फैक्टर. टेक्निक्स फॉर इवैल्यूएशन ऑफ डिसइंफेक्टेंट. सो इसमें दो मेथड होता है, ट्यूब डाइल्यूशन मेथड, अगार प्लेट मेथड, and filter paper or and cup plate method. फिनाल कोएफिशिएंट मेथड, इसके ऊपर क्वेश्चन आता है वो डिटेल में देखेंगे. कैल्सी साइकी मेथड. फिनाल वाटर कोएफिशिएंट. दिस टेस्ट इंक्लूड्स फर्स्ट इन दिस टेस्ट यू हैव अगेन टू. सो रेडियल वॉल्कर टेस्ट, क्वेश्चन इसके ऊपर आ चुका है. व्हाट इज अ रेडियल वॉल्कर टेस्ट. So radial Walker broth is used and Salmonella typhi is used as a sensitive organism. Question इसके ऊपर आता है. Phenol coefficient method is there. So in that you have this radial Walker test or radial Walker test, जो भी जैसे बोलना radial Walker test or radial Walker test. So in this radial Walker broth, that means medium, and Salmonella typhi is used as a sensitive organism. If RW coefficient, radial Walker coefficient, okay, RW मतलब वही radial Walker coefficient. So if RW coefficient is 1, किसी disinfectant का RW coefficient 1 होता है. So if any disinfectant has RW coefficient 1, that means it is as effective as phenol. So it is expressed in terms of comparison with the phenol. Phenol के comparison में दूसरा disinfectant कितना effective है, उसके लिए जो टेस्ट होता है उसको बोलते हैं रेडियल वॉल्कर टेस्ट और आरडब्ल्यू कोएफिशिएंट. सो इफ आरडब्ल्यू कोएफिशिएंट ऑफ डिसइंफेक्टेंट इज 1, दैट मींस इट इज इक्वली इफेक्टिव एज दैट ऑफ द फिनॉल. इफ इट इज लेस देन 1, दैट मींस इट इज लेस इफेक्टिव देन फिनॉल. इफ इट इज मोर देन 1, दैट मींस इट इज मोर इफेक्टिव देन फिनॉल. ओके. सो आरडब्ल्यू कोएफिशिएंट अगर किसी डिसइंफेक्टेंट का फिनॉल के मतलब 1 है तो उसको बोलेंगे इज इक्वली इफेक्टिव एज दैट ऑफ फिनॉल. अगर RW कोएफिशिएंट कम है तो लेस इफेक्टिव देन फिनॉल, ज्यादा है तो मोर इफेक्टिव देन फिनॉल. तो रेडियल वॉल्कर ब्रॉथ एंड साल्मोनेला टाइफी इज यूज्ड एज अ सेंसिटिव ऑर्गेनिज्म. क्वेश्चन इसको. देन अगेन देयर इज अनदर टेस्ट नोन एज चिक मार्टिन टेस्ट. डिटेल में पढ़ना है तो बुक में से पढ़ सकते हो, अदरवाइज नॉट. एंड US FDA टेस्ट इज देयर. सॉरी नॉट US FDA, ओनली FDA टेस्ट. US एसोसिएशन ऑफ ऑफिशियल एग्रीकल्चर केमिस्ट AOAC test. AOAC test is also there is a for इसके फिनॉल वाटर कोएफिशिएंट के अंदर ये टेस्ट आती है. So radial worker test, Chick Martin test, US FDA test, then US Association of Official Agriculture Chemist test. Various chemical disinfectant, their mechanism, concentration, properties and uses. So alcohol is used as a disinfectant in concentration of 60 to 70%. What is the mechanism? Protein denaturation damage to the enzymes, liquid enzyme complex. प्रॉपर्टी क्या है इसका? ये फ्लेमेबल होता है, वोलेटाइल एंड स्किन टॉक्सिटी. इट इज यूज्ड एज अ surface antiseptic, disinfectant and preservative. Then phenol, it is used in the concentration of 0.5 to 5%. So it destruct the cell membrane wall. By destruction of cell membrane, then it causes the protein precipitation also. It is not inactivated by organic matter. So phenol को inactivate नहीं करेगा कोई organic matter. Then disinfectant and antiseptic, it is used as a disinfectant. Now third one is the heavy metals, mercury. Mercury particularly used in the 0.1%. It causes the coagulation of cytoplasmic protein. This mercury is inactivated by organic matter. इसका एक property important है. Silver nitrate used in the concentration of 0.1% causes protein denaturation of bacterial protein. It's a very weak microbicide. मतलब ये ज़्यादा इफेक्टिव नहीं होता, weak microbicide. It is used as an antiseptic and microcidal. Microcidal means way to kill the microbes. Iodine in 2% concentration. Protein inactivation. It is an oxidizing agent soluble in the alcohol used for the skin in disinfection, skin, water and air disinfection. Chlorine compounds, they are used in the concentration of 5%. So it will cause oxidation of protein and enzymes. It is inactivated by organic matter and inorganic gases. It is used for disinfection of water, disinfectant. It is used as a disinfectant. Then for water purification, that is a treatment of water, and also used as an antiseptic. In quaternary ammonium compounds, so in concentration of 0.01 to 1%, they cause disruption of cell wall of membrane. They are colorless, neutralized. Okay, they are colorless compound but neutralized by soap. अगर soap use करें तो उसमें neutralization होगा. Used as skin antiseptic and sensitizing agent. Crystal violet dye used in the concentration of 0.01 to 0.005%. This is the inhibition of inhibit the cell oxidation process. So used as antiseptic for specific group of microorganisms and used as antiseptic and fungicide. So this is a just maximum time इसके ऊपर क्वेश्चन नहीं आता है. It is used in the concentration of 60 to 70%. Protein denaturation, flammable वगैरह होता है वो आपको मालूम होना चाहिए. Antiseptic, disinfectant and preservative. Phenol in concentration of 0.5 to 5% causes the destruction of cell membrane and protein precipitation. Used as a disinfectant and antiseptic. It is not inactivated by organic matter. तो ऑर्गेनिक मैटर अगर कुछ है तो उसमें कोई फर्क नहीं पड़ेगा. Mercury compounds, they are inactivated by organic matter. So used in the concentration of 1%, 0.1%, causes the coagulation of cytoplasmic proteins. Then silver nitrate in a 0.1% concentration causes protein denaturation, very weak microbicidal, used as the antiseptic and microbicidal. Iodine in concentration of 2% causes the protein inactivation. It is oxidizing agent soluble in the alcohol. Okay. So it is used by the skin and water air disinfection. तो स्किन का डिसइंफेक्शन करने के लिए ये आयोडीन. देखो आप पहले ज़माने में ये आयोडीन का ल्यूगोल सॉल्यूशन या फिर ल्यूगोल सॉल्यूशन रहता था, आयोडीन पोटेशियम आयोडीन सॉल्यूशन. तो अभी भी आजकल पोविडन आयोडीन क्रीम होता है. तो दैट इज एंटीसेप्टिक. Chlorine compounds used in the 5% concentration, they causes the oxidative damage to the proteins and enzymes of bacteria. They are inactivated by presence of organic matter and they are used for the disinfectant. They are used as a disinfectant for treatment of water and also used as a now quaternary compounds, they are used in the concentration of 0.01% causes the disruption of cell wall of the bacterial membrane. They are odorless but they are neutralized by presence of soap. So skin antiseptic, they are used as skin antiseptic, then sensitizing agent and preservative. Crystal violet used in the concentration of 0.01 to 0.05 causes the inhibition of cell oxidation process. Antiseptic for specific group of bacteria used as antiseptic. And so this was regarding your स्टरलाइजेशन चैप्टर में ये सब इम्पोर्टेंट है. इसमें किसी को कोई डाउट